Welcome to The Explainer. Today, we are diving into two of the most powerful ideas in all of programming, conditionals and loops. These are basically the secret sauce that makes code smart, efficient, and able to tackle some really complex problems.
So here's the plan. First, we're going to give our code a brain so it can actually make decisions. Then, we'll teach it how to do things over and over again without getting tired. And finally, we'll put it all together and see if we can solve a classic programming puzzle that really tests our logic.
Okay, so let's jump right in. How do we get our programs to stop being, just a dumb list of instructions and start acting like they can actually react and adapt to what's going on? I mean, think about it. You check the weather, and if it's raining, you grab an umbrella. It's a simple choice. Our code needs to be able to do that exact thing. Look at a situation and decide what to do next.
This whole if this, then that, otherwise do something else thing. We do it all the time without even thinking about it. And the cool part is, we can build that exact same logic right into our code.
In C++, the tool for this is the if-else statement. And really, you can just think of it as a fork in the road for your program. If some condition is true, it goes down one path. If not, it goes down the other. Simple as that.
And here it is in action. It's super clear, right? The code checks one simple thing. Is the age greater than or equal to 18? If that's true, boom, it runs one block of code. If it's false, no problem. It just jumps over to the else block and runs that one instead. It's so simple, but this is how you give your program control.
Okay, so making one decision is a huge step. But where programming really shines is in automation. I mean, what if we need to do something not just once, but maybe 100 or even thousands of times?
Just imagine for a second trying to type out the same command 500 times. Seriously, it would be an absolute nightmare, right? So tedious. And what if you needed to change it? Ugh. This is exactly the problem loops were invented to solve.
A loop is basically a little robot you build into your code. You give it a job, and it just keeps doing that job over and over and over again until you tell it to stop. This is the secret to writing short, powerful code that can handle huge tasks without breaking a sweat.
So one of the most common loops you'll see is the for loop. And it's got three basic parts you got to know. First, the initialization. That's just where we start counting. Then, the condition. That tells the loop how long to keep going. And finally, the update. That's what happens after every single cycle, usually just counting up by one.
All right, this is where it gets really fun. We've got decision-making with if-else, and we've got repetition with loops. So what do you think happens when we start putting them together? Right, you put a loop inside another loop. It's called nesting, and it's a total game changer. It's like unlocking a whole new dimension for your code. Suddenly, you're not just working in a straight line. You can think in terms of grids, like rows and columns. Think spreadsheets, checkerboards, you name it.
Okay, check this out. To make this grid of stars, you have an outer loop that's just in charge of the rows. So it runs 5 times, right? Once for each row. But for every single one of those runs, the inner loop fires up and runs completely, printing out all the stars for that column. And just like that, you get a perfect 5x5 square with just a tiny bit of code.
All right, we've got the tools. We've got conditionals, we've got loops, so let's put them to the test. We're going to tackle a classic computer science problem, one that's going to make us use everything we've learned so far.
So here's the challenge. How could you write a program that can figure out if a number is prime? Remember, a prime number is only divisible by 1 and itself. How do we get code to check for that?
Well, the first idea that probably comes to mind is what we call the brute force approach. It's not fancy, but it gets the job done. You just set up a loop to check every single number, one by one, from 2 all the way up to our number. And inside that loop, you use an if statement to ask, hey, does our number divide evenly by this number? If it ever does, bam, we know it's not prime, and we can stop right there.
And look, that totally works. It will give you the right answer. But a good programmer doesn't just stop at it works. They ask, is there a better way, a faster way, a more elegant way? And in this case, oh yeah, there's a much smarter way to do this.
Okay, so here's the big brain moment. You actually don't need to check all the way up to the number. You only have to check up to its square root. Why? Well, think about it. If a number has a factor that's bigger than its square root, it has to have a matching factor that's smaller. They come in pairs. So if we haven't found a factor by the time we hit the square root, we're not going to find one. This one little change makes the code ridiculously faster.
And this quote just nails it, doesn't it? The real magic here isn't just about crunching numbers and getting a result. It's about the creative problem solving, about finding that clean, clever, efficient solution. That's what makes programming such a beautiful craft. So, let's recap what's in your new toolkit. You've got if-else statements, which let your code make choices and follow different paths. You've got for loops to make your code a workhorse that can repeat actions tirelessly. And you know how to nest them to create complex patterns. You literally have the building blocks to solve some really interesting challenges now. So really, the question is, now that you can teach your code to choose, and you can teach it to repeat, what's the first thing you're going to build? What problem are you going to solve? That's all for this explainer. Thanks for watching.